Okay, it's time for advanced math. Unit 12 on vectors, part C, page 4. On the last page, we looked at the definition of a dot product, which is when one of the ways you can multiply two vectors together. And we did that, an example of it, by multiplying the magnitudes of the vectors, two vectors, times the cosine of the angle between them. And at the very end, we did some mysterious math that showed another way that you can calculate the dot product by just multiplying the corresponding components together and adding those like this. So the component of x, the x component of the two vectors gets multiplied, the y component of the two vectors gets multiplied, and you add those results together. And I should add, we're doing this in two dimensions with just x's and y's. If you have three-dimensional vectors, the same process applies, although we haven't proven it. So we're going to try this technique using the same drawing that we did on the last page. On the last page, we got a dot product of, I think, 38.7 just by measuring the angle crudely, but now we're going to do it exactly using this technique and see how similar our results will be. So looking at vector u, um, its components are -2 and +7. So 2 units to the left and 7 units up. Vector v is 5 units to the right and 7 units up. So now we'll multiply the x components. That's going to be -2 times 5 is -10. Multiply the y components. 7 times 7 is 49. Add those results together. -10 plus 49 equals 39. Now, on the previous page, what did we get? Oh, yeah, 38.7. So 38.7 on page 3. That's pretty darn close to 39. And actually, 39 is the correct answer. 38.7, we didn't get it quite right because we had to measure the angle between the two. Now, the angle between these two is not like some whole number of degrees or anything magical. It's a kooky number. Um, so the fact that you can get the dot product of these two vectors as an integer without doing any trigonometry is astounding. Which is to say, if you have two vectors in component form and you've been asked to multiply them together using the dot product, do not graph them tail together, measure the angle between them, measure their lengths, and use the magnitudes multiplied times the cosine of the angle. It is true that that works, and that's okay, but don't do it. In reality, really avoid doing that because it's hard to do and it's time consuming and it's unnecessary. If you've got the vectors in component form, use the component form of the dot product all the time. So let's try an example of that. I have two vectors now, u and v, and I want to compute their dot product. And I don't need to put them together tail to tail. I don't need to measure their angle. All I need to get is their components. So components of u are, looks like it's 4 units to the left, and 1, 2, 3, 4, 5, 6, 7, 8, 9 units up. So that's components are -4, 9. V has a horizontal component of -7. I'm counting 7 units to the left, and it's down 2. So that's a y component of -2. And now the dot product of u times v is multiply their x components together, so it's -4 times -7. Add to that the product of their y components, 9 times -2. So 4 times 7 is 28. And we're going to be subtracting 9 times 2, so 18 equals 10. 10 is the dot product of vectors u and v as they're drawn here. Oh, that's so nice. Right, next up we're gonna have part D.